everyone, Joey Pickardt, German audio engineer and guitar player, and today it's part 4 of building up a modern metal tube amplifier. So we have talked about power amp, preamp, power supply, what's left, the fixed loop and the phase inverter. But in my last video I talked about the preamp, and if you haven't watched the series, maybe you start at the front. Today it's part 4, so maybe the 3 parts before are interesting. In part 3 I mentioned 2 things not in my explanatory, and I want to deliver that in this video, so we start with the preamp. Let's get into it. There we have it. Yes, that's looking good. Okay. Getting the guitar, it's not that comfortable to have the Explorer. It's nice for the arm like the truckers do, but on a desk it's maybe a bit complicated. But okay, let's start. Maybe I lay it down. Okay, that's better. What I forgot to mention are 2 things. First, the switching. I only talked about the switch above here, but the channel switching, of course, is done here in the preamp because there is a clean and a lead section. So down here you can see the input of the switching. One is for channel switching and the second one is for the reverb that I'm planning. And the channel switch is operating in the very front here with a relay on the lead and clean gain input putties behind that to select between those putties, and the other side is at the very end of the equalization at the volume out and presence regulation of the channels. And here, by the way, you can see I'm doing a presence without a feedback loop. So it's like it is done in the Mesa Boogie rectifier. Normally, if presence would react to the would get a feedback from the power tube output from the very end of the power stage from the transformer, and you would feed it into the phase inverter, and then there is an equalization that is behaving not like a typical preamp equalization. But I like this way. I like that I can choose in my amp that it's operating without reacting the presence in the power amp section. But we will hear it later, I think. Okay, and the last thing here down with channel switching is an photoelectric resistor on optocoupler that is muting the lead channel output when we are in clean channels, so there shouldn't be so much talk over from the gain that is maybe produced or overtaken from the circuit while the clean channel is on. This could happen, and this is muting it, so you are dead quiet in the clean channel and you don't have gain in your signal while you will want to play clean. I hope this works. Okay, the second thing that I forgot to mention is I talked about a lot of how the gain is shaped. This as an addition to my explanation in the last video. This is all depending on the frequencies. All this the distortion shaping is depending also on which frequency, how much distortion you have, and this is done by all the filtering, by the capacitors, by the tubes themselves, and how they are operating. And so this is like an equalization distortion combination what is happening throughout the tubes in the preamp. And at the very end of this last tube does not have the function of an of more gain and gain and gain. It is distorting, so, but I don't place it here to get more gain. The 5 preamp tubes triodes are enough. I place it here to get a powerful equalizer. You can see it's not placed like the others. It don't have an anode resistor here. It's directly connected to UB4. And this is done because if you connect the output signal on the cathode, and you can see down here the cathode resistor is much higher. It's like in the other tubes, the anode resistor. You will get no phase inversion, but you will get a stronger current flowing into the equalizer, and therefore the equalizer can shape the tone better and can sound tighter, and you get more range out of the equalization. These are the two things that I don't mention. There are a lot of other details that I could go into, but I don't do it. It's too much to do a science class about this. It's enough, I think. Okay, then if we have this nice chunky metal sound like this one is coming out of a UAD plugin from the Diezel Herbert at this time, but if we get it out of our preamp, then we maybe want to use reverb, or we want to use delay or a noise gate maybe, and we need amplification for the power tube and have to prepare the signal. So let's have a look at this schematics. Let's look at first, because this is the easiest one, I think, at the noise gate. Or no, let's get the amp complete and then look at the noise gate. So here it is. That's the part I talked about, and I have done 2 versions because after I started to build up this project, I decided to build 2 amplifiers. So one amplifier will be with this build up, and one amplifier will get a complete tube set up. I will tell you in a second why. What we can see here is the FX loop, the phase inverter for the power amp section, and a digital reverb module. Let's start at the front. This is the feeded signal from the preamp, and we're going into the FX loop module that I use from TubeAmp. It's a prepared module that you can solder up and place all the parts on it, and after that you connect it to your high voltage and you will have a working FX loop. But it's based on high voltage MOSFET transistors, so yeah, it's not that true for a tube amp, but I was interested in using this. After building it up and seeing it and building it into the amplifier, you will see it in the next videos, I'm not that happy. It works, but I want to have here a working tube later in this amplifier. So I built up one with this one, but the final one, or the second one, will get a real tube output. Okay, what we can see down here is a digital reverb unit from the company called Belton. It's connected parallel to the FX loop, so yeah, you can use the digital reverb without any connection externally from the amplifier, and you can adjust the amount of reverb for each channel, clean and lead, after this over the this relay and this relay. So this is a circuit that is connecting the reverb on and off switch together with channel switching, so you can on and off select the reverb, and you can use different potentiometers to adjust the amount of reverb in each channel. what I'm also doing in this amplifier, where can I see it? Where is it? Okay, here is it. I'm driving over this relay the LEDs for the indicator light for clean and lead channel. So this relay is switched by lead and clean selector, and I'm using the 6.3 volts from the heaters to drive through a resistor my both LEDs, blue and a red one. The blue one is getting another resistor because it's quite bright, and this is for indicator lights at the front. Okay. I think I don't need to talk about this much more. I can I put a link to the tube amp board I used here, but it's a transistor board. It's not a tube board. So yeah. That's about the FX loop. Let's jump into the another circuit with the tube FX loop. Here we have it. The rest is the same. The channel switching down in the indicator light, but I don't use a reverb in this schematic. I just wanted to have a truly straight through tube amp circuit without any schnuggums. So you see I added a tube here and two input jacks and a circuit that is used and a bit modified. You can find that circuit in a lot of amplifiers. Tube amp FX loops are quite near the same in much different amplifiers that you can find, because there's not a lot of sound shaping here. This FX loop should work as if it were not there. So we don't do many equalization or many distortion. We don't want to have any coloration at this point. We just want to have a working point. And also you can see we're getting out here at the cathode. It's similar to the equalizer output. We don't need that high signal, but we need a strong signal because we don't know which FX loop are connected to the FX loop. If you have a low or a high impedance input at the effect you are using down here. The input is mostly the same like in a lot of preamps, but only we have a very low resistor against ground, because the signal that is getting into our loop return is much stronger from the typical transistor devices that you connect here. Okay, that's the big difference between the two circuits with transistor or tubes, and I like this much more. It's less, yeah, it's more straight. Okay. In both circuits we have the same phase inverter circuit, and let's talk about this. Okay, remember as we talked about the power amplifier, we said we have a positive and negative half wave amplifying power tube, and we need to have our signal that is driving those both tubes phase inverted for the lower tube, so that it can get the direct opposite of the upper tube in the power amp circuit. I maybe will blend the schematics of the power tube in here later. And how we get it, this is happening here. So let's have a look at this. The main point how it works, we use two triodes and we fed it the signal from our FX loop over the master volume. So here is my master volume adjustment, and we get our signal into this circuit, and we have down here a bridge between different resistors, And the second tube is getting that what is left from the signal, but not really a lot of the signal. It's just attached to a pretty steady point, and it is performing always the opposite of the input. So if here the volume or the sine wave takes a negative phase, or the voltage on this point is getting lower, then the voltage on this point will get higher. This is mainly the secret of a phase inverter. And after this, the signal, of course, like in every tube here, is amplified. And the amplified signal is phase inverted. And then we have it. We have the phase inverted signal, positive or negative sine wave, with the absolute synchronized form fed into our power amp. You can also see here's a slight difference between the resistors. I saw a lot of explaining videos to this, and it's always said that this is needed because this one doesn't get the signal input. But with measurements, if you look at it, you will get a not synchronized working phase inverter in this circuit, and this is wanted. I think they are doing mainly a shifted performance, so you can get if you get into power amp tube distortion, you get a shifted or a not typical hi-fi performance, and therefore you get a nice growl, a sound shape into the power amp section. This is my opinion on this resistor, why they are not the same. Last but not least, we have a feedback from our transformator, output transformator, from the 8 ohm tap, and it's feeded back into our phase inverter, so we get a bit control into our power amplification setup, but not much. I'm doing a lot of damping here. And you can see down here, I don't think I will realize this one. This is a preamp presence regulator that we saw in the preamp at the end of the equalizer. And here, this is how you would build it up when you use a power amp presence. I will test it, but I think I won't use it on this position. I will use it in the preamp like the Mesa Boogie rectifier, because I like that operation. Okay. Last but not least, I said it before, but now it's really last but not least. Let's talk about the noise gate, because if we don't have a noise gate, we will have an amp. This is a noise gate activated, and if I deactivate this noise gate, let me get the Diezel Herbert plug in here. Okay, I deactivate the noise gate now. You can hear it's not that nice, and now I activate it. That quiet, that's what we want. Okay, how do we get it? This is the only point that I use transistors, because we only need something that is opening a resistor or changing a resistance of a photoelectric or an optocoupler, and closing it when we are not playing. So there is noise gate, please open. There is small noise, background noise from the preamp, please be quiet. So we need something that perform this open and close procedure, and we can adjust the point where it closes and opens, the threshold, typically it is called. Okay, let's have a look at the schematic that I come up with. Here we are. This is a modified circuit that I found as easy noise gate. on different web pages, and I modified it to my needs. I can blend in a short video now. Okay, what I have here is now a bit of experimenting and the final result. On the right you can see, wait a second, I stopped that noise. At the right you can see my experimenting platform with a built-up simple noise gate, and the output stage, or the stage that is muting the signal, is an optocoupler device, so a photoelectric device that is connected at one half to the noise gate circuit, which is supplying a high or a low voltage according to there is sound or there is no sound, depending on the threshold. And on the other side there is a resistance that is reacting to the light emitting diode that is inside here, like in old Fender tremolos. Mesa Boogies using this type of channel switching and muting in their circuits, so they're pretty common in tube amplifiers for switching and stuff like that. So this side, the side behind here, is doing the muting to the audio circuit, and my audio signal is on the red wire going into a simple amplifier here in my workshop, and the audio input signal is going into the circuit here at the right, and is coming from two your distortion devices. So I have a super overdrive from Boss and a TC Electronics Fangus metal here connected to each other to get massive tons of gain, and as you can assume, these both together are pretty noisy. So if you're playing that high gain sound, it isn't a joy to listen to that when you don't have a noise gate engaged. So okay, this is the experimenting platform, this is my sound generating part. I have a guitar here, and this in the middle is the final result out of my part testing on the circuit that I am going to put into the amplifier. The whole circuit, the test circuit and the real circuit that I put into the real amp, are connected to the battery, not quite now, but in a second, and both are getting the input audio signal from the same input. My test board has the optocoupler, the photoelectric element. This board has just a light emitting diode, so you can see that a voltage change applies in a light on or light off adjustment on the LED here. And let's get started and listen to some very noisy sounds. So I start this Bose. You can hear the noise, I think. And as soon as I connect the battery, the noise is gone. Okay. A bit louder. And the noise is gone. And you can see this little fella here is going to emit light, because this little fella is emitting light 2 in the other circuit and is muting the signal to ground. So this signal is muted to ground when this light emitting diode inside of this little enclosure is emitting light, and the photoresistance is getting less resistant by the light. Now let's hear some tunes. I hope it's not too loud now. the threshold is not completely adjusted, but I'm going back a bit of volume here, and in the output it's quite loud here. Okay, that riff without the noise gate. Okay, I think you can get it what this noise gate is doing, and it is doing really good. I also tried out a little resistor against ground in series with the optocoupler, so I have not the absolute quiet muting. It is just going down maybe 30-35 decibels, and this is nice when you play, so you don't have the total silence. So if you want to play gent, maybe it's better to get the muting totally, but in the most cases I think it's nicer to have a bit of left volume in nearly hearable volume while the noise gate is closed. So you won't get any feedback, but you hear that your amp is still alive and it's getting a bit more organic while you play. And you can hear it worked. I needed a lot of tweaking to get there. I needed to change a lot of resistors and to modify it to get it working with an optocoupler, because in the original drawing it is performing with an MOSFET transistor. But now it works quite nice. And a very short explanation from me. You can see I simulated something here. Just assume that we get a signal into the circuit at this point, our guitar signal, and this is the power supply, DC power supply from my amp. I'm using I think I will use the heater voltage, quite filtered, hopefully, or maybe a drop down resistor with an Z diode. This is quite an experiment that I've not done yet. Okay, let's start. Here there is an capacitor that is proceeding our playing, but not the maybe DC part that is coming through. And we have a resistor parallel, and this transistor will open and close while we perform something at the input. So if there is a signal, it will open and close in forming our signal. And now there is an interesting point. You can see here two diodes, and two diodes, one from the ground to the signal, the amplified signal, and one in the signal way. And this is acting like a rectifier. In our power supply we use rectifiers, I explained it there. And the sine wave here, the positive and negative sine wave, are passed through and directed at the same phase. So the negative is directed to the positive side of the sine wave. And after that, we have a filter capacitor. So it's mainly like we have a rectifier part in our signal chain, but at the input we have a high impedance against the whole circuit here, so our real signal won't get any disturbance from this circuit here. But we're getting the information, not the current, but only the information of the signal into the circuit. And after that, we rectify it, and then we have voltage, no voltage, voltage, no voltage. And this is what we want. And the point how much voltage is the point where it opens and closes can be adjust it with this capacitor. Of course, I'm not using a potentiometer as a capacitor. This is old stuff and not really functionally good. And we need a really high capacitance. For a regulator you won't find it. And you can adjust the amount of signal you feed into that circuit, and with that you get a working noise gate. So we have on off here at this point with the voltage, and a capacitor that is discharged when the gate opens, but not really. So this will leak pretty slowly against ground until it is leaked. And this point here is delivering current and voltage to the diode, to the capacitor, and to this transistor. And if the transistor gets voltage at this point, then it will flow current and drop the voltage against ground. This capacitor will discharge, and when it has discharged, then this LED, what is also discharging the capacitor, will stop emitting light, and our photoresistor will stop muting, and our signal will pass. So we are changing the phase of the signal and the form of the signal again and again, but in the end this is working. So I think you could see it in the short video. It works fine, and the circuit is pretty compact and small for a noise gate. Yeah, I was happy when I finished it, and I hope it will do a great job like this noise gate in this Diezel. And for that, this is the input for today. I hope you had fun. Like me, subscribe me. I'm happy when you learned something or you comment something that I did wrong here. Tell me what I can do better maybe. And yeah, what's left to say? Oh yeah. We've done everything in circuit design, so the next time we see us, we will lay our hands on something. So I hope you all are happy about that, because it's a bit dry stuff for now, and in the future I hope it is getting to a real project and not just theory. I'm looking forward to that, and I'm happy when you watch the series that I'm putting out, and I promise I will do, and I will do it until the end, and there is a ready working amplifier that we can talk through, and it will sound awesome. See ya, till next time.